In this video, we are going to draw this spanner, which involves concepts of polygons and just basic tangency. The most useful tangents that are going to be drawn here are arctangents. So we're going to be using the information that we know to draw this arctangent. For example, we've got an arctangent here of radius r22, which is a tangent to this circular part and the tangent to this line. We also have an arctangent here, which is a tangent to this point and that point. The most striking feature of this question is that we don't have radiuses that have been given to us here and there. Additionally, we also don't have this radius of this curvature here. How can we find them? Well, this won't be so difficult. We are going to use our polygon. If you can see, we've been given a polygon here, which is partially a hexagon. You can see we have this shape here. If we were to complete here and there, we could have our hexagon. So if you realize that this is a hexagon, well and good. The next thing you should realize is that we've been given this distance 38, which is the distance between two opposite sides of our hexagon. That distance is known as the distance across flats, and it will be very helpful in this particular question. So let's start with drawing our hexagon and then going step by step, seeing how we can attempt this question. So we'll decide where we'll place our hexagon. Let's say I place it here. This is where it will be. I'm going to measure a distance of 38, which is my diameter. After measuring it, I can mark it on this line. So you can select any starting point, mark an arc like that, and another one like that. We have got two arcs. Then we bisect this distance. While we bisecting, we want to be able to have a radius. Then we'll join these 2 points here, like that. Then this point here is the center of this distance. So practically the distance from this center to that end point should be 19 millimeters. How 19? Because our diameter is 38, our radius is supposed to be 19. So here you could also just realize that you needed a radius of 19 and go directly. But picking your diameter is the more general method in case you have a number like 39. 39 divided by 2 will give you some radius with a decimal point, and you're not really able to mark decimal points so well with a compass. So we'll stand at this point, open to the mark there, which should be the same as opening to the other mark, and then we'll draw a circle. After we have drawn this circle, we need to draw our hexagon using the method of distance across flats. The most important thing here is looking at the orientation of your hexagon. You can see that it's got its flat sides here, there. I'll try sketching that so that you can actually visualize it better. We've got a circle like this, and then we have our hexagon. In full, it will look like this. This is how it should look like. So these two sides here are not part of our drawing, but when analyzing, we should really see them. So the easiest is drawing this side. The first time we draw it, because we don't know all the sides of our hexagon, we're going to just draw it in construction pencil. So we'll draw it like that, construction pencil. Make sure this line is at 90 degrees with this other one. The easiest way is to use your t-square and your set square. After you have done that, now we need to know the points of tangency. If you remember, I'm just from sketching here. This side is a tangent to the circle at a particular point. So we need to find this point here, and this point here. To do that, we'll use our 30-60 set square. We'll use our 60 side, this one here. Then we'll mark a line through our circle that passes through the center like that. And then do the same with this other side of 60, and then we're also going to have a point that will be generated. So this is the point of tangency, and now we'll use the other side, 30 side, and then draw our side of the hexagon. And then we'll also draw the side that's in this position. Why I'm drawing these sides is because I know both where they're going to start. So on this line and ending on this line. So if I outline like that, I have my hexagon nice and easy. Then I outline this part here. The only side that remains is the one on the left top there. Before we draw it, we will need just a small construction line here to show us where our side is supposed to end. After we have that construction line, we'll go to this point of tangency with our set square using the 30 side, and then draw a line. So that shouldn't be very difficult. The next thing is now using our diagram to an advantage. So in this diagram, when you look at it very carefully, you can see we've been given some arrows. Those arrows are very helpful. For example, we've been given an arrow that starts from here up to there. This arrow here is indicating that the radius of this circular part is gotten from standing at this point. Since it's a radius, and if we follow the arc, we can see it comes to this point, and we have this point which is the end of our side for the hexagon. So if we stand here, open to the end, we'll be able to get the radius of this circle. Similarly, if we stand at this point, open to the end of the side of the hexagon, we are going to be able to draw the circle that is supposed to be giving us this part and that part. So let's do that and then see how far we'll get. So we have got two circles. The next thing is now drawing this part here. This part is an arctangent. If you realize it's an arctangent, the following step shouldn't be so difficult to visualize. What type of arctangent is it? Well, it's an arctangent that we can get if we have two circles like this, and then if we subtract the radius of the circle from the radius of the arctangent for both circles, given the centers, we can have such an arctangent. Now the problem here is that we don't have that radius of the arctangent. If we look in our diagram, we don't have it given to us. But if we look carefully, we have been given the center of the arctangent, something that's not very common. So how do we treat such a situation? We have the center of the arctangent, the center of the circle to which the tangent is touching, and like that. Well, if you can remember, we have a line that joins the center of the arctangent to the center of the circle, which is the normal in terms of arctangency. So the first thing that we should try to do is see, can we draw a line through these 2 points? Can we locate this point very easily? Of course we can. You can see that we've been given an angle here which is 60 degrees. This is 60 degrees. So we will draw that line. With the help of our set square and our t-square, we can measure that angle easily. This angle here is 60 degrees. So we won't need to construct any angles, we just need to drop a line like that. After we have dropped this line, we can also utilize the fact that this point here lies in line with these 2 points. So we'll use a straight edge, join the end point of our sides, the end point of this side and this side, we join them together using a straight edge like that, and we have this point here. We can call this point T so that we can easily refer to it. So we'll join point T and this point of our hexagon because that's where our arrow is. So T and the center of our circle where the arctangent touches. And then we also have another circle on this other side. In short, what we have done here, we have now located our radius and our point of tangency. The point of tangency is here and there. The center of our arc tangent is there. So if we open to the point of tangency, it's as good as getting our radius. So the only thing that remains here is drawing our arc tangent. So make sure you have a nice dark line. After we have that nice dark line, we also outline our circles that we earlier drew. Make sure it's dark enough. Do the same on the other part. Before you draw, just ensure it's touching all the points that it's required to touch. So we have this part of our spanner clear and done. The next part of our spanner is this handle like part. The first thing you need to realize is we've got a center line here. This is very important to understand for this part. Even in our hexagon we had this center line, but I didn't talk much about it. So let's draw that center line. We can use our t-square to our advantage. Come to this point here. Okay, that's our center line. We can make it go all the way, but yeah, it can be fine even there. In such drawings, it's always important that you draw them as exactly as you can see. So it would be a good idea that you draw this center line before you forget it. So we'll come our set square like that, then draw a center line. Just make sure as you draw it, it looks neat. Don't draw it too long that it starts being something that is confusing. Okay, so we can get this 22 divided by 2 and then mark two parallel lines at the top and the bottom with that 11. So I'll go to my ruler, mark 11, and then you can mark a parallel line, or if you like, some people won't like drawing those two parallel lines, you can, on this line that we have, just draw a small vertical line, and then on this line you mark your distances. Then using a t-square, you can just draw a line from this point going to your left and from that point going to your left. So these lines I draw are in construction. I only outline them after I have drawn my arc tangents. So you can see that's my part with the handle. Additionally, I can know where this this handle part is going to end. You can see I've been given 130 from this side to this point. It's very important. Now before we do that, let's work with these portions. So what we'll do here is the same thing that we'll do even there. Our task is to use this R22 to our advantage because we have been given it. On this part here where this R22, which is the arc tangent, touches the line, we'll just directly get the radius of the arc tangent. So I'll measure 22 with my compass, then draw a parallel line. I'll stand at any 2 points, strike an arc like that, and another one like that. Since the bottom part is the same as the top one, I'll do the same. You can select any 2 points, draw an arc like that, and another one like that. Then at the top of these arcs, with the help of a straight edge, you draw a line. So you align the top of this arc and the other one, draw a straight edge like that. Even for the ones at the top, we do the same. Line the top parts, I join the straight edges like that. Make sure it's long enough. It should be longer in this area. Next, we now are supposed to add some radius. We'll add the radius of the arc tangent to the radius of this circle here. Now the question here comes, how are we going to add the R22 to a radius that we don't know? Remember, we just got this radius here from the side and then drew it. In this case, at this step, we're going to be required to add the radius of this circle and the radius of this arc, which is 22. The easiest way to do that is just picking your distance here, distance of the side, taking it to a ruler, measuring it. In my case, it gives me 21, so I'll get that 21 and add it to the 22. That gives me 43. So using the 43, I'll stand at the center of this circular part, or the circle where the arc tangent is touching. The center is this point here. Stand there, then strike an arc like that. On the top part here, yes, it's a similar arrangement, but this arc tangent is not touching the circle that's here. It's actually going to touch our area arc tangent. So instead, we're supposed to measure the distance from point T to this point here. If I measure that distance, it gives me 50 millimeters. So I'll add 50 millimeters and 22 millimeters, which gives me 72 millimeters. So standing at point T, the center of this arc, I'll come and then strike an arc. The next step is something we're used to do in arc tangents. It's joining the center of the arc tangent to the center of the circle where we're going to have arc tangent touching. So one of the circles here is this one here. The center is there, the center of the arc tangent is here. So we'll join them like that. You can see it's interestingly the same point where our area arc tangent with the center from T there is supposed to touch. The next thing is also knowing where our tangent is going to touch on the line. How we do that is you draw a line at 90 degrees with the line which the tangent is touching. So you can do that with just your t-square and set square. You draw it like that. So the angle here is 90 degrees. We'll do the same at the top in advance with our set square. So from T2, this is where our tangent is supposed to come and touch. And then on this part here, we need to draw a line from point T to point T2. So this is where our arc is going to touch the other arc tangent. So we'll get a compass, stand at point T1, open to the point of tangency, which would be the same as the other one there. Then draw an arc. You can see I have my arc tangent, which looks nice. Then stand at T2. You can see I haven't changed my radius and I still have the same points of tangents. This is what should be happening even when you draw. Everything should just fall into place. So we have our handle drawn. You can see we are progressing from this part to this part. Now let's locate this end point, which is 130 from this side. To do that, we can use our compass, measure a distance of 130. Remember, we're working in millimeters, so that is the same as 13 centimeters. The easiest is looking at a line that we have that goes all the way. We can measure from the center line here, like that. It can be a good idea for us to mark this part with a straight line so that it's even more visible, like that. I'm using a construction line. So we've got this point here and this point. The next step is going to involve arc tangency still. If after you locate these 2 points, the end points of our handle, this one and that one, you just get the 22 radius and stand at this point and mark to get the point where you're going to draw your arctangent. You won't have this type of arc. You have one arc that is more circular. You have something like this instead of something like what we have been given. So to locate the center of this 21, we will need to measure that 21 millimeters. It's an arctangent to a point and point. Then stand at the point where the arctangent touches, strike an arc. The other point, you also strike an arc. This point should be exactly on our line. So we'll stand there with our actual radius, then draw our arctangent, just like that. The only part that remains to be outlined are the straight edges. This is how you could draw this question. It's not very difficult. It just involves you understanding how you draw your arctangents. And there is our spanner. You can see our information that we used and the result that we have there.